Welcome back. Here's page 3 of 2.1. Let's get started. Describe the graph, much like what we were just doing back here, where ultimately we ended up doing what's referred to as completing the square, so we could find the vertex and give a description of the graph. But we're also supposed to find the x-intercepts, so that's where the graph crosses through the x-axis. Now understand, if I have a parabola, which all of these are, perhaps it crosses through twice, perhaps it only touches once, but it's also possible it may live entirely above or below and have no x-intercepts. So there could be 0, 1, or 2 solutions for that. But let's start with our completing the square. F of x equals, nice, nothing times x squared, so this is x squared plus 10x, leave a blank, plus 14. Half of 10 squared. That's 5 squared, 25. I put in a plus 25, which means I just added 25 to this side. I need to subtract 25 to keep it identical to what it was. This is x plus 5 squared. 14 minus 25 minus 11. Identify the vertex. So the vertex is at my vox. Here's f of x equals, is at my vox negative 5. When x is negative 5, this whole thing is 0 minus 11. So there's our vertex. And identify the vertex, the x-intercepts, and describe. I guess I'll just describe it here. Looks just like regular old x squared, except it is left 5, down 11. It's growing at the same standard rate because this is 1 times out in front. Now we have to find the x-intercepts, and to find the x-intercepts we could go quadratic formula, but if I've got it in this form, rather than quadratic formula, I think I would do this. X plus 5 squared minus 11 equals 0. Watch this. This is x equals, I need to add 11. I need to then, once the 11's gone, I need to get rid of squared. How do we get rid of squared? Hopefully you didn't say just square root. Plus or minus square root of, plus or minus square root of 11, and then we subtract 5. So our x-intercepts are at negative 5 plus or minus square root of 11. And you can probably kind of see that that could come from quadratic formula. You're welcome to do this quadratic formula with the initial. And if they just ask for the x-intercepts, I would do quadratic formula. But if they want the vertex and I'm going to standard form, I'm really only one big step away from here to there. Okay. F of x is negative x squared minus 3x plus 4. I'm not going to make that mistake. I need to complete the square, so I'm going to factor out a negative 1. X squared plus 3x, leave a blank, plus 4. And perhaps you could have done that in one step. And then I need half of 3 squared 9/4, so that's plus 9/4, but I really just subtracted. When I distribute, that's a minus 9/4, so I need to add 9/4 here. So I get negative x plus square root of 9/4, 3/2, and let's see, that's 16/4 right here, plus 9/4, 25/4. Not the prettiest. Oh, I need a squared. So our vertex is at negative 3/2, my vox. When x is negative 3/2, this is all 0, negative 0, 0. 25/4. So this is really a big part of the description of the graph. We are left 3/2. We are upside down, and then we are up 25/4. And now, if I take this function right here and I set it equal to 0, watch this. X equals. Now I've learned a little bit here. I like that square root of 11/2 to the right. I'm going to subtract 25/4. I'm going to, once I subtract 25/4, the next thing I want to do is rescue this negative, multiply both sides by -1, so this is actually plus 25/4. I've now gotten rid of the 25/4 and this negative. I'm now ready to get rid of the squared, so that is plus or minus. Here we go. I guess I'm going to do this. X is getting kind of messy. X is plus or minus square root of 25/4, which is nice and convenient, plus or minus 5/2. I've gotten rid of the squared. Now I just need to subtract 3/2. And you can do that in multiple steps, but I would really encourage you to practice that. So let's see. Negative 3/2 plus 5/2 is 2/2. X equals 1. Negative 3/2 minus 5/2 is negative 8/2. Negative 4. There's our x-intercepts. So they actually ended up being nice and clean, even though it started out looking like they might be messy like this. Okay, 36. F of x equals, factor out negative 4. X squared, careful, minus 6x. Always distribute back and double check. Minus 4x squared plus 24x, good. Minus 41. Half of 6, 3 squared plus 9. Careful, when I did this, when I put the plus 9 in there, minus 4x squared good, plus 24x good, minus 41 good, but minus 36 bad. Balance it, plus 36. So we get negative 4 times x minus 3 squared, FOIL if you want to double check it, minus 5. So our vertex is at myvox 3 when x is 3. F of x is negative 4 times 0 squared minus 5, negative 5. Description, we are right 3, 4 times as tall, which means over 1 is normally up 1. Now over 1 is going to be up 4. Over 3 is normally up 9 on regular old parabola. Oh, but actually it's going to end up being down. But over 3 would now be up 4 times 9, would now be up 36. But we are also upside down. Right 3, 4 times as tall, upside down, and down 5. So now if I take negative 4 times x minus 3 squared minus 5, set it equal to 0, I end up with x equals. Let's see, I need to add 5. I need to divide negative 4. I take the plus or minus, so that makes this plus or minus or plus, square root of, so I've gotten rid of the 5, added 5, gotten rid of the 4, divided 4, or negative 4, taken the plus or minus square root of, now I just need to add 3. So I get x equals 3 plus or minus square root of 5 on square root of 4, 2. Could we do that in multiple steps? Absolutely, but challenge yourself with it. Challenge yourself with it. Ultimately, it becomes quicker, but ultimately it becomes safer as well, believe it or not. So, just an alert. I don't know for sure. Each of these problems had 2 x-intercepts. We have 2 here. We have 2 here, nice clean ones. We have 2 here, but you may only have 1 intercept on one of these. You may have no intercepts. Very possible, because graphs could live entirely above the x-axis, just kiss the x-axis, or it goes through it twice. Okay, I'm going to show you 2 ways to do 38. The way the book expects you to, and the way that I think would be a really, really great approach, and some of you are going to get this. So, first off, our standard equation is y equals a times x minus h squared plus k, and it's just puzzle pieces. I need to know what a is, I need to know what h is, I need to know what k is, but here's what I know. I know that h is -2, I know that k is -1, so right now I've got y equals a times x minus -2 plus 2 squared minus 1. I've got 2 of my 3 puzzle pieces when they give me the vertex. And now the book is expecting you to do this, and this is great. I have no problem with this at all. This 0,3 has to be worth something to us, and I just need to find out what a is. 0,3 can go in for x and y, so I get 3 equals a times 0 plus 2 squared minus 1. 3 equals 2 squared 4a minus 1. So 4a equals, add 1, 4. A equals 1. So my equation is just y equals 1 times x plus 2 squared minus 1. Now, what I would do for this is I would say, okay, yeah, we have y equals a times x plus 2 squared minus 1, but take a look. This graph from the vertex to this point goes over 2, up 1, 2, 3, 4. What would our regular old parabola do? If I put in 2, I'd get out 4. Regular old parabola goes over 2, up 4. This is what I refer to as standard growth. It's growing at the absolute regular rate and regular direction of x squared. So a is 1. Y equals x plus 2 squared minus 1. Let's just talk about this briefly, 37. A is not 1 because this opens up downward, but look at this. From this vertex point to this point, we go over 1, 2, down 4. Regular old parabola is over 2, up 4. The only difference is it's upside down. That should be a big hint what A equals on problem number 37. And there is page 3.